All right, so in order to figure, right now we've got the triangles up there. The next thing we want to do is we want to try getting ourselves closer to determining the edges, which edge belongs to which surface. To get the edges, before we get there, we need to figure out which surface each triangle relates to. So I've got this script over here that effectively highlights each triangle. Instead of doing the border, it does 3 lines through the center of it. But it highlights each one related to which surface it's forward. So the top facing one goes to white. The green is for forward facing, red is this facing, the other side is yellow, the back is blue, and the bottom is pink. And this is being shown, so when I did this, I could test and I could demonstrate and make sure that every one of these showed up exactly on the sides I was expecting it to. All right, so let's start diving in. The first key thing here to look at is that we have the surfaces listed out. It's 6 of them, but this is going to be a proof of concept, so I'm not exactly counting the array inside. I know it's going to be 6 coming in. All right, so let's go on to the code. Get rid of that window. And inside of here, one of the key differences we immediately see is that we now have a class triangle. Triangle holds on to its positions, and it holds on to the normal for the vector, and it also holds on to the surface that is related to that triangle, because we need to identify that, and every triangle will need to be compared with that information. Okay, so inside of the onDraw gizmo selected, there are going to be 2 more functions after this. We'll get to them when we need to. We go ahead and get the vertices and the triangles using the shared mesh again. This time we're creating a dictionary of colors using the NavMesh surface as a key. So each surface is a key to unlock a different color. When we have the upward facing surface, we have blue. When we have the upward facing surface, we have white. My surfaces are actually in reverse on this. So the upward facing surface is actually backwards. 5 is my downward facing surface. And I'll get to that in a minute. But it did separate out the surfaces, and I fixed the normals later. It still identifies the triangles correctly. They're just reversed for which sides they go to. All right, and the culprit will be the normals, as we'll see in a minute. All right, so, and a special call out thanks to Taylor from Princess Castle Quest, because he helped me through the math on this one. I ended up getting it in here, but then had some serious bugs along the way, and so this needed to be fixed. Okay, so anyway, inside of this, we have our length. So we go through each one of the triangles in the triangle array. So that's groups of 3, just like we went through before. We create a new triangle. We set its positions. The positions the same way we did before. Each vertex inside of there is going to be the triangles index passed into the verticals index, or as the verticals index. So we end up getting those 2 pieces of information, passing them through each other, and we get the vertex for that position. And then we do this for the same thing for I+1 and I+2, which is our triangle indexes. All right, then we do the same thing to get our normal in here. And in this one, I am doing a vector cross of the index 1 minus index of 0 and index 2 minus index of 1, and get the normalized, the cross product normalized. Now, this actually ends up giving me my numbers backwards. So that doesn't work, but it identifies enough, because when we look at this actually shows up. So I had this error in my code, but it still allowed me to move forward. Anyway, in later videos, we're going to fix that anyway. Okay, and then I get the surface associated with that normal. Now, I did something a little backwards here as well. So when we are getting this surface, let me go down to that function that gets it. We pass in the normal for that surface, and then over here we say, hey, which surface is closest to this? Which technically, since the normal is backwards, we are doing this in reverse. Which angle is farthest away from it? What's the farthest angle? Which 180 degrees. So anyway, we're going through these ones and we're finding out which angle is the farthest one, and then that relates to the surface, and it generally works. We still see that identification of triangles being identified correctly, even if the colors are wrong. Okay, so back up here, we've gotten the surface for the triangle, and we add the triangle. Now we're going to go through all the triangles one by one. We're going to get the triangle, then we are going to draw it. I could have used a for each here. That would have been fine. It would have been easier. I could have cut out a lot of this extra superfluous work. So over here we have draw triangle, and I wanted to keep, a lot of times I like to keep the sub functions to be simple so they don't care about custom classes. unique to the script, unless there's some real strong benefit there. So in this case, I just passed in vector 1, 2, and 3 for the triangle and the color associated with it. Okay, so first off, we're setting the gizmo colors. Then we're creating a new vector3 array. Technically, I could have just said v1 equals transform.transform point v1 and did the same for v2 and v3 and just used v1, v2, and v3. But for some reason, I turned it into a vector3 array. Whatever. Anyway, so now I go on, and what I'm doing is I'm taking those 3 points of the triangle, and instead of drawing lines to the outsides, I'm drawing a point from one of these to the middle of the other one. So when you look at this, it's going from 0 to the average of v1 and v2. All right, and it does the same for the v1. It goes to v0 and v2, and v2 goes to v1 and v0. So we draw the lines crisscrossing through it. So this triangle right here actually has the line going from this point straight through to the middle of these two, and then from this point straight through to the middle of these two, and etc. All right, and that draws the lines, and that's the last part of this. We now have these uniquely identified. That was the key of what we were trying to deal with here. So that's done.